So let's talk about soil real briefly. 3 major classifications. You've got your sand, silt, and clay. What we want to take away from this is that the sand is the largest particles and the clay is the smallest. And we want to focus on the larger the particle, the larger the space will be between those particles. And so in the smaller the particles, the smaller the space. That water, now we're talking about adhesion and cohesion, clings to those particles, and the thicker the layer of that water on that soil or that particle, the easier it is to remove. And so picture a drop of water on your finger, pretty easy to shake that water droplet off, but there's a film remaining, right? That small film gets harder and harder to remove. The less distance it is from, or the closer it is to the particle, the thinner that layer, the greater that adhesion force, and the harder to remove that, which becomes challenging later for soil tension. So, in this graph, you can see on the left, that's saturation. So now we've in those spaces between the particles, we've completely saturated, filled it up beyond the point that adhesion can hold that water in the soil, and so it starts to drain out. Gravity overcomes. Field capacity is now we're finding that equilibrium in between that gravity and adhesion and cohesion, and so now that's the maximum amount of water that soil can hold. As we start to draw that down through the plants or any other means, drying that out, we start to move toward a wilting point. That wilting point is now, like we talked about, that layer of water is now getting so thin on that soil particle that the adhesion is so great, the plant can no longer pull that water from that soil.